Hello, welcome once again to Mathematics Media. This program has been helping students in mathematics, especially those students that are in secondary school. Those in higher institution, we also find some of the topics here interesting. Okay, we have been looking at theory of logarithm, and we have been able to look at the meaning of logarithm, and we also look at important points in logarithm. Now we want to look at the laws of logarithm. That's the second objective. Remember, we brought out 5 objectives that we need to cover in the study of what? Logarithm. And we said that definitely we need to know the meaning and important points in logarithm, so we'll know the laws of logarithm. Then we also look at how we can simplify terms and expressions involving logarithm. Then we say that we also look at logarithm of numbers by substitution, and then finally we look at equations involving logarithm. So far we have looked at the first objective, and we are about starting the second objective. As usual, there is need for you to stay away from all forms of distraction and get ready for this beautiful adventure. Now, it is also important that you like our Facebook page and also subscribe to our YouTube channel, because it will go a long way in enhancing and publicizing these videos. Thank you. Now let's begin without wasting time on the laws of logarithm. Now, if we will solve problem in logarithm, if we will simplify terms and expressions in logarithm, if we are going to solve equations in logarithm, definitely the laws of what? Of logarithm are important. You know that laws are very necessary. Without laws, we will have anarchy. So in order to avoid mathematical disorderliness and mathematical anarchy, we need laws in indices. If not for the laws, there will be disorderliness in what? In logarithm. That's why it's important that you follow me as we study these laws. We will need to quote these laws, just like lawyers quote Constitution of Nations in a law court. When we come to the court of mathematics and we want to judge a case on logarithm, then it is the law of logarithm that we are going to quote. All right, so we have about 7 laws that we are going to look at, about 7 of them. So let's begin. Let's begin without wasting time. So the first law, so we are going to list them and explain them. Then in our subsequent videos, we'll now see how we can apply these laws in simplifying what? Terms and expressions involving what? Logarithm. So let's look at these laws of logarithm. Number 1, the first law. If I have log m in base a plus log n in base a, it is the same thing as saying log m times n is multiplication now, m times n in base a. We are coming to explain that. If I also have log m in base a minus log n in base a, the same thing as saying log m divided by n in base a. Then, if I have log m raised to power p in base a, same thing as saying p log m in base a. If I also have log a now in base a, it is 1. That means logarithm of a number to its own base, or in its own base, is 1. Okay, we'll still look at that. Let me write 1 in words. Is 1. Is 1. We'll still come back to that. Okay, then we have log 1 in base a is equal to 0. That means logarithm of a number, of 1 now in any base is 0. Okay, then the sixth law, let's use the other part of the board now. Let's use here. We'll have this. Okay, then we have the sixth law. We have log n raised to the power n when the power is on the base. We looked at that, the power is on the number, is something like 1 over n, 1 all upon n log n in base a. And then the seventh law, we call it the change of base law. If I have log m in base a, we are going to have 1 over log a in base m. Now I'm using any letter. Remember when I define logarithm, I use b just to be a base, a to be the number. So here I can still use any other letter. The base can be any letter, it can be anything. So it's not necessary, it's not that b is the base, no. We just use that to explain logarithm. Now, these are the 7 laws, and they are very, very important if we are going to solve problems on logarithm. Now, let's explain them. What exactly is the first law talking about? What exactly is the first law of logarithm talking about? Now, look at it. There are 2 things of interest. Number 1, the operation between these 2 logarithms is what? Addition. Then the second thing is that they have the same word, base. They have the same base. Now, when you have 2 logarithms, or 2 or more logarithms of the same base, take it again, 2 or more logarithms of the same base, and the operation between them is what? Addition operation. All we need to do is to multiply the numbers under their common logarithm, because this is common to these 2 logarithms, log a, log base a, log base a, log base a, log base a. So we multiply the numbers under their common logarithm. So if I use number, if I have log, let's say I have log 4 in base 10 and plus log 25 in base 10, and I want to reduce it, I can only use the first law. Why am I using the first law? This logarithm and this logarithm are of the same base, that's one. And then the operation between them is what? Addition operation. So I can write this base 10, then 4 times 25. 4 times 25. And that will give me log 100 base 10. We'll go further. By the time we start simplifying, we will not leave this like this, but we are not going there yet. We are just trying to show what this first law is talking about. So log 4 in base 10 plus log 25 in base 10 will give me log 100 in base 10. How did I arrive at this? I used the first law. Why did I use the first law? The 2 logarithms, they have the same base, and then the operation between them is what? Addition. If I have maybe log 54 base, let's say I have log 27 base 3 plus log 8 base 4. I cannot apply the first law, even though the operation here is addition like we have here, but the bases are not what? The same. So the first law can only be used when the bases are the same and the operation between the 2 or more logarithms is what? Is addition operation. I think that is clear. Now the same thing similarly to the second law. The second law. We are still going to apply these laws in solving problems. So in the second law, when the operation is negative and the logarithms are of the same word, base, what we do is to use the second number to divide the first number and place them in their common word, logarithm. So if I have log, let's say I have log 32 base 5 minus log 4 base 5. This is going to give me log 32 over 4 in base 5. So use the second number, the number in the second logarithm, to divide the first number the number in the first what? Logarithm. That's this, which is this. So you look at that. Remember, the bases are the same and the operation now is subtraction. Very important. If I have log 50 base 10 minus log 25 base 2, this cannot work because the bases are not what? The same, even though we have a subtraction operation here. All right. The third law is the power law. Now, the third law, when the power is on a number in logarithm, this is a number in the logarithm. When the power is on the number in a logarithm, then that power is the same thing as the number multiplying the what? The logarithm. So you see this power here is still the same thing. So I can write this like this or like this. This and this are the same. The same way this and this are the same. This and this are the same. So from here I can go to this. And from here I can still split it. Let's say I have log 5 times 4 base 10. I can write it as log 5 in base 10 plus log 4 in base 10. So if I have logarithm like this, I can decide to split it like this. If I have logarithm like that, I can decide to bring it to this form. So the laws are, they are in two ways. They are reversible. Let's use that. We normally talk about reversible reaction in chemistry. They are reversible. So this can move towards that. This can also move like this. So if I have log m raised to power p in base a, it's something as saying p log m in base what? A. So when I write this and this, they are the same thing. Now, you now look at the problem you are trying to solve. The form you are going to express it depends on the problem you are going to solve. If writing it like this will help me solve my problem, maybe the equation was given in this form, and for me to solve the problem, I needed to put it like this. That's the only time I can transform this to this form. Then if maybe what I was given is in this form, and I know that there's no way I can evaluate it in this form, then I need to put it first in this form. So the form or the direction that you are going to take depends on the nature of the equation you want to solve. So log, let's say we have, if I have log 5 raised to power 2 base 10, something as saying 2 log 5 base 10. When the power is on the number, that power is the same thing as the coefficient of the what? Of the log. I think that's clear enough. Then the fourth law, the logarithm of any number to its own base will give us what? 1. So log a in base a will give us what? 1. Log 2 in base 2, log 2 in base 2 is 1. Log 10 in base 10 is 1. Log ek in base ek is also 1. All right. Log Nigeria in base Nigeria will also give us 1. And when you say log United States of America in base United States of America, we still have what? 1. So logarithm of a number to its own base will give me what? 1. So when the base and the number are the same, the result of that logarithm will be what? 1. That's the fourth law. Very important law. Then we have the fifth law, that log 1 in any base is what? 0. Log 1 in any base. So logarithm of 1 irrespective of the base is what? 0. So if I have log 1 in base 10, it's going to give me 0. Why? 10 raised to power 0 is still what? 1. You remember that. The logarithm of a number is the power of the base that will give us the number. So what will I raise, what will become the power of 10 to give me what? 1? That's 0. That's why log 1 in base 10 is 0. So if I have log 1 in base Britain, I'm going to have 0. If I have log 1 in any base at all, let's say in base China, I will have 0. If I have log 1 in base Igbo, I will have 0. If I have log 1 in base Hausa, I will have 0. I will have log 1 in base Yoruba, or we still have 0. Sorry. So logarithm of 1 to any base is what? Is 0. Log 1 to any base is 0. Alright, then the sixth law. We are just trying to explain all this so that by the time we begin to solve problem, when you see a particular problem, you just open the files of your head and say, oh, this is the particular law that will be suitable for this problem. So the sixth law. Now in the third law, we have power on the number, but in the sixth law, we have power on the what? Base. The power on the base is something as the reciprocal of the coefficient of the law. So you look at this. The power here, this is reciprocal. Reciprocal means 1 over a number, reciprocal of a number. So when the power is on the base, it's the same thing as 1 over that power, then times the what? The log. When it is on the number, it's just that number that will multiply the log. But when the power is on the base, it is the reciprocal of the what? Of that power that will multiply the log. Then finally on the seventh law, we talked about the change of base law. I have log m in base what? A. Now if I make A the number now and B the what? Sorry, and m the what? The base. I have to turn the expression upside down. You see that? So it means that if I have log 2 in base 3, something I'm saying 1 over log 3 in base 2. You look at that. So when I change the base and the what, when I interchange the number and the base, and we invert the what, the logarithm, or invert the logarithm. If we use symbol for the sixth law, that's the sixth law now. If we use symbol, if I have log 7 in base 2 raised to power, let's say 3, that will give me 1 over 3 log 7 base what? 2. That's what we are going to have when the power is on the base. Take note of all this. Take note of all this. I know that you are enjoying this meal, and so far you have been able to take note of the laws of logarithm. Remember, whenever you are given a logarithm, it's very, very important that you know which one is the base and which one is the what? The number. And when we want to mention logarithm, when we want to read logarithm, we read the number first before the base. For example, here we know that this is now the base and this is the what? The number. So if you want to read this, it is log m in base what? A. So log m in base A is read as log reading of m in base A. Failure to identify the base and the number means we are going to have a problem in trying to solve problem in logarithm. All right. Thank you for following us to this point. Remember, we started with the meaning of logarithm in our first video. It's important that you lay your hand on that video, watch it. Then we are now on the laws of logarithm. Don't be in a haste. Somebody will say, oh, solve problem, solve problem. No, we are not going to solve problem until we have laid the necessary foundation. Very, very important. Very, very important. All right, we are going to end the second episode of logarithm here. We're going to end it here. And then in the next episode, we are going to start with simplification of what? Of terms and expressions involving what? Logarithm. Even before we start solving problems, then we need to describe them and explain their nature before we now solve problems. All right. Till I come your way again, continue to enjoy mathematics. Remember, a meal a day. A meal a day. A meal a day from mathematics meal can end mathematical stupidity. Thank you, and God bless you.